Good morning everyone. My name is Vineeta and today we will be studying about the formation of backwater curve in gradually varied flow. So, moving towards gradually varied flows, basic assumptions and all. As we have studied in the previous lecture, the dynamic equation of gradually varied flow, and it was change in depth with respect to the distance x was termed as SB minus SE upon 1 minus V square upon 2G. In our previous lecture, we have derived this dynamic equation of gradually varied flow with its assumptions, and in that we can see that we can conclude dy over dx or change in the depth in the channel with respect to the horizontal distance covered by it gives what? Three conclusions with it, that is, if dy over dx is equivalent to 0. If dy over dx is equivalent to 0 means there is no change, y is constant, and since y is constant we can conclude it as it is having a uniform flow. Next one, if dy over dx is greater than 0, that is, it is giving a positive value. Positive in the sense there is a rise in the water level, or you can say this rise in the water level in the stream is termed as backwater curve. Backwater curve. And third one, if we find out dy over dx, that is change in depth with respect to horizontal distance is less than 0, then we are having negative value, that is there will be a drop down in the water surface level of the flow, and that is resulting into section of drop down curve. The basic equation or the dynamic equation is given three sections, that is, if it is 0, that there is no change, then obviously we are supposed to get it as uniform flow, it is verified, and if it is greater than 0 means there is a change with respect to the distance covered by the channel, it is positive, and that result in the formation of backwater curve. So, we are supposed to study about backwater curve in today's section. So, we will be studying how we are going to calculate backwater curve. This we can see in the diagram, you can see this is a channel of span x. Let us suppose it is having an x section to be covered, and here it was, you can see here it was y, let us suppose it is y1, and if you calculate or measure over here, y2 is greater than y1. This section, why it happened? This is the rise in section, that is this particular term will be what? y2 minus y1, and this is known as efflux or backwater curve. This section will be known as efflux or backwater curve, means efflux or backwater curve result in the increase in the water level due to obstruction. You can see this is an obstruction, weir sort of kind of thing is there, and due to which the formation of water goes back, and you can see after certain span, after traveling water after traveling certain value, it is increasing gradually, and you can find there is a huge change between the initial depth and final depth, and this change or this increase is known as efflux. So, we are going to calculate the distance between this section where efflux formation is going on. So, you can conclude as you can see that what is backwater curve? Backwater curve is the rise in the level in the stream, the upper side, and the length to be covered, length to be measured from the section it starts moving, rising from one section to another. This you can see where it is having the maximum height, this is the maximum height of rising, and it started over here. From here to this point we can term it to as length of backwater curve. So, we need to calculate the length of backwater curve in any stream or channel. Now we can calculate, or we can see, this is datum, we can draw the backwater curve section 1 and 2, or you can say this is datum, right. It is having a slope of SB, let us suppose. Then this is your depth y1 and y2, and this will be your head loss, right, HL. This is what, V square upon 2G. This will be depth at another section. Let us suppose this is section 2 and this is section 1, right. So, we can denote this will be V2, this will be Y2, right, or you can say this will be Z1, this will be Y1, and this will be V1 square by 2G, and this will be the energy slope. Let us suppose it is having a span of L kilometers or L meters, which we need to calculate. And what we are supposed to do, due to the rise from section 1 to 2, we need to calculate this distance L, or the expression for this distance L, right. Or you can say at section 1 and 2, we can apply Bernoulli's equation, that is total energy over here plus total energy over here should be constant. Applying Bernoulli's equation, we can see that Z1 plus Y1 plus V1 square by 2G. That is all about section 1 is equivalent to what? Z2. Is there any Z2? There is no, actually there is no value of Z2. We can substitute it and we can later put it as 0. Z2 plus Y2 plus V2 square by 2G plus this head loss over this section, Now, you can conclude what we can write to this. In our previous lecture, we have studied in specific energy. What is specific energy? Energy, total energy equation, and if we are calculating it above datum, not considering it the datum, then what we are having? Specific energy. Since terms are E of one section, we can substitute it as Z1 plus E1, right, equal to Z2 plus this will be E2 plus HL, right. From the diagram you can see that what is Z1? What is Z1? How we are going to calculate Z1? SB into L, right. We can take another pen. Here you can say Z1 can be substituted as SB into the distance L. Next one, HL. How we are going to calculate HL? It can be SE into L. SE into L. Let us substitute these value in the above equation. What we are getting? And this Z2 tends to 0. It do not exist. It tends to 0. Now, you can see Z1 is how much? SB into L, or you can write in another one, Z1 plus E1 is equivalent to Z2 was 0, E2 plus HL. From the previous equation we can see that Z1 and Z2 HL with further values SB into L plus E1 is equivalent to E2 plus SE into L. We can take, since we need to calculate L from the basic equation, we can take the same terms in one side. This is positive, it will be negative. L is equivalent to E2 minus E1, or you can say L SB minus SE is equivalent to E2 minus E1, or Lastly, you are getting it as change in specific energy, that is E2 minus E1 divided by change in their slope. Bottom slope and energy slope will be giving you the length of backwater curve. This we were supposed to calculate the length of any channel where backwater curve formation is being calculated or being observed. You can calculate it by this further equation. Now, next one, since we have studied about gradually varied flow, its dynamic equation, its various forms based on different categories. Now, we need to study about the classification of gradually varied flow, or you can say we are supposed to study about the various sections of various situations of formation of gradually variation of flow in the channel. Basically, it is being broadly categorized into 5 profiles, and further those 5 profiles are further subdivided into sub profiles. So, let us first study about the basic or major categorization of this gradually varied flow, under which you can see it is termed as mild slope, steep slope, critical slope, horizontal slope and adverse slope. Before moving towards all these slope, all these conditions, we will revise, although we have studied in our previous lecture what is normal depth, critical depth and depth at any section. I will remind you of once again what is normal depth yn, what is yc and what is y. Yn is the depth at which given discharge flow uniform. What is Yn? Either it is the case of gradually varied flow, uniform flow or rapidly varied flow. There is a depth in that particular channel in which or at which the discharge can be treated as uniform one, and that particular section can be termed it to as this normal depth. I can show you or visualize you by a diagram. You can see over here, this is the datum, right. Suppose this is the section of change, gradually varied flow you are having, gradually varied flow, and here you can say suppose this particular point is y, right. After certain section you have got it as y dash. Now, this is the case of gradually varied flow. We can assume if there are no changes, let us suppose if there are no changes, this y1, y will be equivalent to y over here. That is, if you see the case of gradually varied flow, there lies one depth which behave as uniform flow, and this particular depth will be terming it to as yn, that is normal depth, a depth at which given discharge behaves as uniform flow. Yn is done, y normal. Now, yc is critical depth, it is the depth at which specific energy is minimum or least, and y is any depth at any section of gradually varied flow. Based on these depth, normal depth, critical depth and any depth of gradually varied flow, we have categorized broadly gradually varied flow or formation of gradually varied flow into 5 categories, that is mild, steep, critical, horizontal and adverse. The very first condition we can see that first one, and their representations are corresponding: mild for M, steep for S, critical S, C, horizontal H and adverse A. And further we will be studying the conditions for it. Conditions means how we are going to identify that particular section is having any of them, any of the profile within it. First condition is if depth of flow of normal depth is greater than critical depth. Now, what it is? You can see this one. What was the condition actually? Condition was if normal depth is greater than critical depth, right. Let us draw the diagram. This is datum, and datum for a discharge to be possible, this will be, let us suppose this is critical depth yc. The depth or the line passing through yc will be CDL or critical depth line, Now, above this will be one normal depth to it. Let us suppose this is yn, right, normal depth above it, and the line passing through normal depth will be terming it to as NDL or normal depth line. You can see whenever there is a condition where normal depth is greater than critical depth, or you can say the flow is in subcritical section. The flow is in subcritical section. That particular condition can be termed to as mild slope. Similar this you can see it. This is red one is CDL critical depth line, and this one dotted one NDL normal depth line. Further, we will be categorizing or studying in our next video about the M1, M2, M3 formations. Basically, for this one, first we need to study about the y relationship between Yn and Yc, that is mild slope. For mild slope, what we have studied, if Yn normal depth is greater than Yc, this we have seen. Next one, steep slope. Steep means what? You are having a positive slope. Steep means steep valley, positive slope, you are having slope in positive value, or you can draw steep value. Steep one, you can see that this is, let's suppose SB, and it will be positive. See, since you can see or you can visualize it, it is having so steep value, critical depth, normal depth line will be below critical depth line, because critical is the value which is fixed, right, for any dimensions, and if you are providing slope in extra, means that particular value will get down to the CDL value, and here you can see that this is your Yn and this is your Yc, that is, you can see your normal depth line is less than your critical depth line, and this particular section will be known as steep slope. Here you can see this is your normal depth line, NDL normal depth line, and this will be critical depth line. Third one, critical slope. Third one is critical slope. Critical slope means what? When you are having your normal depth line or normal depth is equivalent to your critical depth, that is when Yc is equivalent to Yn. When Yc is equivalent to Yn means there will be no change in NDL or CDL. This is datum, this will be your Yc and this will be your Yn. Reason being Yn is equivalent to Yc, and it will be critical flow at normal depth. Next one, moving towards, and similarly you can see another one, this one critical one, the same CDL or NDL coincide with one and the same, and they are having the same value, Yn is equivalent to Yc. Next one is horizontal. Horizontal itself you can see that, what is horizontal? Horizontal means plane, right? Plane means you are having zero slope, slope is 0. A section where slope is 0 and in a gradually varied flow can be termed to as horizontal slope. Here you can see Yn can be infinity and Yc will be according to the channel, and there you can see that slope is 0 and it will be terming it to as horizontal slope. And the last one, fifth categorization is adverse slope. Adverse means opposite conditions, and slope, opposite slope means what? You will be having slope in negative value. Negative value means you need to understand this particular value will be in negative. Water needs to flow opposite to gravity, that is S naught is less than 0 or negative. Here you can say in any of the conditions flow cannot be uniform at any condition. In both of these section you can see for horizontal and for adverse condition you can never find, or it can never sustain uniform flow within it. Else you can see for mild, steep and critical you can say they behave accordingly. At critical means critical flow, and at Yn less than Yc you can see Yn is less than Yc means critical. Here I can draw, if this is the base, this is the critical CDL, right. This will be supercritical section and this will be subcritical section. Then obviously, if normal depth is greater than YC, that is if it is over here, then this particular section flow will be in subcritical section. This is what we have written as remark. And then you can see Yn is less than Yc, here you can see it will be lying in supercritical section, and then the remark is at supercritical section. This is all about basic categorization of gradually varied flow into 5 major sections: mild, steep, horizontal, critical and adverse. In our next slide, we can study about the further categorization of mild and steep profiles in detail, that is formation of M1, M2 and M3, S1, S2 and S3. That is all for today. Thank you.